Today, we're going to learn about absolute value equations. The absolute value breaks up into two equations. So why is this the case? Well, let's take a simple example. The absolute value of x is equal to 2. Now we know the absolute value of a negative number becomes a positive number. So if we had the absolute value of negative 3, we would get 3. But there's another way to get 3. The absolute value of 3 is also 3, because the absolute value of a positive number doesn't change it. We can have positive 2, the absolute value of positive 2 is equal to 2, or we can have the absolute value of negative 2, which is also 2. So both of these lead to solutions. So every absolute value equation is going to have two solutions. As you can see in this first problem, one way to solve the expression is to pretend that the absolute value doesn't exist. Now, why would that be the case? Well, it's because, first of all, a positive number isn't affected by the absolute value. So that would be one of the cases. And in this case, if we give x a value of 4, then we have 4 plus 2 in the absolute value symbol. And we know that the absolute value of positive 6 is just 6. So that's the equivalent of removing the absolute value in the first place. X plus 2 is equal to 6. Because in this case, we'll subtract 2 from both sides and get x is equal to 4, which is what we found in the beginning. So 4 works. Now what else works? Well, if our expression in the absolute value is equal to negative 6, the absolute value converts it into positive 6. So if this value is equal to negative 6, the absolute value of negative 6 is equal to 6. So that's the equivalent of essentially removing the absolute value symbol and making the 6 negative. Because if what's in the absolute value can be negative 6, then that's the equivalent of removing it and making the term on the right-hand side negative 6. So we can actually rewrite this as x plus 2 is equal to negative 6. Now let's solve for this. If we subtract 2 from both sides, we're going to get x is equal to negative 8. Now let's try it. If we plug in negative 8 here, we get negative 8 plus 2. That's negative 6. The absolute value of negative 6 is equal to 6. So it works. So in this situation, we have two answers, 4 and negative 8. And so if we were to plot them on the number line, it'd be here and it'd be here. The absolute value of y minus 4 is equal to negative 3. So let's do the same thing we did in the previous problem. Let's split it up into two equations. One is where the absolute value doesn't exist, and the other one is where it's the same thing except the right-hand side is multiplied by negative 1. In this case, 6 was converted to negative 6. In this case, negative 3 will be converted back to 3. So let's solve these equations. Let's add 4 to both sides for this one. So we get y is equal to 1. And this case, we'll add 4 to both sides as well. And we get y is equal to 7. So for the second one, we have values of 1 for number 2 and 7 for number 2. Lastly, we have the absolute value of 3z plus 3 is equal to 9. So let's do the same thing. 3z plus 3 is equal to 9. On this side, we have 3z plus 3 is equal to negative 9. On this side, we're going to subtract 3 from both sides. So we have 3z is equal to 6. If we divide by 3, we get z is equal to 2. On this side, we subtract 3 from both sides. We get 3z is equal to negative 12. And let's divide by 3 again. And we get z is equal to negative 4. So these are the two answers to this one. So this is number 3. This is also number 3.